Hi everyone, we're Team 131, and our project is called Data-Driven Analysis of Workplace Safety using OSHA records. We're going to share a quick overview of our proposal. Every year, thousands of workplace injuries are reported to OSHA, but the way this data is shown right now is pretty limited. Our goal is to use public OSHA data to analyze, visualize, and predict workplace safety trends. We want to find which industry and states are most at risk, understand what kinds of hazard are most common, and track how these patterns change over time. We'll also look at whether enforcement activities like inspections are linked to better safety outcomes the following year. Right now, most OSHA dashboards are static and siloed. They usually focus on a simple count, like how many injuries happen in a state, but they don't combine multiple data sources or show clear trends over time. Enforcement data is often studied separately, so you can easily see how inspection connect to injury rates. This scape gives us a chance to build something more useful and integrated. Our approach brings together three main OSHA datasets: severe injury reports, enforcement records, and the injury tracking application into one combined panel. We build clear heat maps and trend charts that show injury rates and hazard shift by state, industry, and year. We also look at whether stronger enforcement in one year is followed by few injuries the next year, using simple fixed effects models. Finally, we'll put this all into an interactive dashboard that helps users explore these patterns in a straightforward way. This slide shows a snippet of our inputs. We join ITA, SIR, enforcement data and store everything at state NAICS year. Then let us compute TRAR DART rate and track severe injuries and summarize inspections violation. Then we use heat map, trends, and T to T1 leg views to test whether enforcement is followed by improvement. This work can help safety officers, regulators, workers, and even journalists understand where risks are highest and how they are changing. We measure impact by seeing how well our predicted hotspot match actual severe incident and by gathering feedback on our dashboard. The main risks are gaps in the data and the fact that correlation doesn't prove causation, so we'll make sure to communicate uncertainty clearly. We plan to clean and merge the dataset and build initial visualization by the middle of the semester. By the end, we will have the full dashboard and the enforcement analysis finished, along with our final report. Since the data and tools are free, the main cost will be our compute on AWS. We believe this timeline is realistic and will give us a strong result. Thank you, everyone.